Hey, Algebra 1. These are the notes for page 17 in your notebook. We're going to start naming something called polynomial. That's something with, a whole string of x's and raised to exponents and things like that. So a constant is degree 0. So this would be like if you had like the number 7 or -2. Even if you had like x to the 0, because x to the 0, is equal to 1. So a constant doesn't have any letters associated with it, or the letters cancel out because it's raised to the 0 power. The next one is called linear, and this would be if it's raised to the first power. So if we had like x to the first or 2x, and that could be raised to the first, it is raised to the first, we just don't have to write it, or 2 over 3x, something like that. But we could also put like +4 at the end, or we could put +1 or +7. That would be a linear situation where your highest exponent in your whole equation is done. The next one is called quadratic, and that means that our highest exponent in our whole string of our equation is raised to the second power. So we could have something like x squared plus 2x minus 3. Because my highest exponent is 2, it's quadratic. Or I could just have x squared, that could be quadratic, or I could have 7x squared plus 5, things like that. Those are examples of it. Cubic would mean it's raised to the third power. So in our equation, we could have like 5x to the third. And my pen's scooping. 5x to the third plus 2x squared plus 5x minus 2. Or we could just have, something alone. We could have like -7x to the third. That's cubic. And then the fourth degree is called quartic. And this means my highest exponent in my equation is to the fourth power. So I could have 5x to the fourth minus 3x to the third plus 2x plus 1, something like that, because my highest exponent anywhere in the equation is raised to the fourth power. So that's naming them by the highest exponent or the degree. The degree is highest exponent. Okay. Down in the middle part of the page. Then we can name it based on the terms. So monomial, we would have one term. Example of a monomial would be like 5 or 7x or 10x to the third. Because we only have one term, there's only one term in any of the equations. Then we have binomial. Binomial means you have two terms. So this could be like 3x plus 4, or you could have 7x squared minus 3x. If you only have two terms, it's called binomial. A trinomial has three terms, so this could be something like 5x squared plus 2x minus 7, or you could have, something with a higher degree, so 8x to the 10th plus 4x minus 2, something like that. After trinomial, it becomes something called a polynomial. A polynomial can have any number of terms. So you could have something huge like 7x to the fourth plus 3x to the second plus 8x plus 2. That's a polynomial. We have more than one term being held together by addition or subtracting signs. The leading coefficient is determined by the highest exponent. It's the highest exponent base number. And we'll see some examples of that as we progress a little bit further. Remember, if you need to finish your quiz, please come in and see me during an off period. I'd like to have it done by Friday this week, if that's possible. Okay, so standard form means our x's are in descending order, so standard form is this. We didn't have to rewrite it. Our leading coefficient, as we look at our highest exponent, which is to the first power, our leading coefficient is the 7, it's whatever that. Name this by degree, so it's first degree, so this is called linear. And name it by the number of terms. There's two terms. It's called a binomial. The next one, this is already in standard form as well. I didn't have to rearrange the order of it. My leading coefficient is going to be, I'm looking at my highest exponent, so my leading coefficient is going to be the base number 3. We're going to name by degree. So if we name this by degree, this becomes, so go back and say, okay, to the second power, that was called, to the second power, quadratic. Okay. And we have three terms. We have 1, 2, 3. Remember, a term is separated by addition or subtraction. So if you name this by number of terms, this is called a trinomial. Okay, standard form is just like this. My leading coefficient is whatever at the base of the highest exponent as far as the number goes. Named by degree, this is a trinomial, or excuse me, this is cubic. And then we only have one term, so that's called a monomial. And I just realized you guys don't even have this page there. So we're just kind of following along, just seeing how things work. Standard form, 9x to the fourth plus 11x. Okay, my leading coefficient is the 9 because my highest exponent is 4. And there are two, highest degree, so this is quartic. And there's two terms, so that is a binomial. Standard form is just this. My leading coefficient is just 5. Named by degree, this is called constant. And then number of terms, this is a monomial. Okay, this one, if we want to put it in standard form, we want to rewrite it to be in descending order based on our exponents. So notice I had to flip-flop the 7x squared and the negative 2x to the third. Keep the signs the same. My leading coefficient here is a negative 2. Degree, this is cubic. And number of terms, this is a trinomial. If we had more than 3 terms, it would just be called a polynomial. And again, I know you don't have this page, but we can just walk along and just see how they work. All right. We're going to be adding and subtracting like terms, which is great. So take a look at the first one. So first thing I'm going to do is I'm going to look at my highest exponent. So I have it to the second power, to the second power, and to the second power. So we can combine those together. So negative 4 plus 2 is negative 2. Negative 2 plus 10 is 8. So I get 8x squared. And then we're going to go take a look at our next part. So I have negative 2x, negative 4x, negative 15x. So that's negative 6x. Negative 6x minus 15 is negative 21x. And then my last things I have 3 plus 5, that's 8. Plus 11 is 19. 19 minus 15 is 4. So this is a trinomial, okay, because there's 3 terms. Our highest exponent is 2, so we're going to call this a quadratic. And this is, and our leading coefficient would be the 8. Okay, example 2, I can drop the parentheses on the first set. That's easy. On the second set, if I distribute a positive over, none of the signs change, so I can just drop the parentheses. And on the third set, I can drop the parentheses because it's just distributing a positive over. So it appears that my highest exponent is x squared. Okay, so ready? 5 plus 3 is 8. 8 plus 1 is 9, so I get 9x squared. Then I have my negative 10x, negative 4x. We combine those together, we get negative 14x. And then 10 plus 1 is 11. 11 minus 11 is 0. So here's my term. So this is a quadratic. because it's raised to the second power. That's my highest exponent. It is a binomial because there are only two terms. And my leading coefficient is 9 because the 9 is attached to my highest exponent. Problem number 3, we can go ahead and drop the first set of parentheses because I don't have anything right in front of it other than a 1. I can distribute a positive over, so none of the signs change. So go ahead and drop the stuff. And on the last one, I can just go ahead and drop my parentheses because I don't have anything other than a positive. So x squared is my highest exponent. So let's add things together. So 3x squared plus 1x squared is 4x squared. 4x squared plus 12x squared is 16x squared. Then I have negative 20x minus 4, that's negative 24. Negative 24x plus 12x is going to give me negative 12x. Then I have 9 plus 1 is 10. 10 minus 4 is 6. So this is quadratic because it's raised to the second power. It is a trinomial because I have 3 terms. Remember, a term is separated by an addition or subtraction sign. So trinomial. My leading coefficient is that 16. Then we want to take a look at the shapes. Okay, so remember the perimeter is the distance all the way around. So if this side's x plus 3, this side's also x plus 3. If up on top is x plus 6, it's also x plus 6 down here. So our perimeter is equal to x plus x plus x plus x. So that's 1x plus 1x plus 1x plus 1x, which is 4x. Then I go 6 plus 3 is 9, plus 6 is 15, plus 3 is 18. So the perimeter around the shape, if we add those types of things. Okay, let's take a look at this one. We have to figure out what this side would be down here. So think about it. This side is this combined with this. So let's add those together. So I'm going to get 3x, and then positive 1, negative 1 cancel out. So this length of this side is just 3x. Then I want to figure out how big this side over here would be. Let's see how big that would be. So the whole distance is x plus 2, right up and down here. But if I subtract x from that, I just get that to be 2. So now I can find the perimeter of my shape because I have all my sides. So I have 1x, that's 2x. 2x plus 2x is 4x, 5x, 8x. Then I have my numbers. 2 minus 1 is 1. 1 plus 1 is 2. There we go. We just combined all of our like terms. So the important thing on these is you want to make sure you get the side, all the sides figured out. So you just use a little bit of logic to figure those out. Our homework for tonight, I think we would be set to do pages 19 and 20. And it looks like on 19 you have to fill out that form. So definitely go back and look at your notes to see how they're called for standard form and leading coefficient and naming by degree and number of terms, okay? So remember, on my notes, you don't necessarily have this page, so you might want to pause your video on this page when you work out the homework, okay? So I'm going to do page 19 and 20, and I think you can do 1 through 18 all. But again, you can pause the video because I'll go right back to that screen. If you pause the video here, this is going to help you fill out that grid for 1 through 10. So go ahead and do page 19 and 20, 1 through 18 all. Have a nice day.